Bismillahirrahmanirrahim. Today we will discuss about overview of programming translators and problem solving steps, how we can solve a specific problem. So first of all, we will discuss some basics about computer systems programming. In our previous lecture, we discussed about overview of programming languages. So when we just use specific language to talk with the computer or to give a specific task to the computer, now we need a specific translators or compilers or that just help to translate our language for the computer. So parts of the computer system, we have two different types, two different parts of computer systems, that are softwares and hardwares. Softwares are specific set of instructions and computer programs that just help to perform specific functions. However, hardwares are the electronic devices present or connected with the specific computer system. In hardware, we have for giving some input, we have keyboard and mouse. For system unit, we have RAM and CPU. For output units, we have monitor and printer and secondary storage devices like hard drives and different types of drives. These concepts are very basic for you, but I just want to recall our memory for these specific points so we can specifically understand our topic. What is softwares? Softwares are specific set of instructions to give to hardware to perform a specific type of task that we want in actual. A set of instructions, it is called a program, driving force behind the computer. Without a program, what is a computer? Collection of useless hardwares. So if you don't have a specific program for a computer that can just perform a specific task for you, so computer is just a useless hardware or just a useless machine for you if you cannot take your specific task from the computer with the help of different programs. So two purposes we have: to instruct the computer what to do, or to give specific set of instructions to the computer to what to do and in which manner you have to perform it, and tell other people what we want the computer to do. So what is the CPU? It is the central processing unit, considered as the brain of computer because it performs all the functions are just employed in that specific area of hardware of computer. So retrieve specific instructions from memory and execute it for the specific task. So after that, we have memory as a RAM. So it stores specific types of information, and the instructions of softwares are also stored in RAM that was executed by CPU. A program and its data must be brought to memory before they can be executed. Before execution, all the data present in the memory just have to recall and run that specific set of instructions for specific tasks. Stores intermediate and final results of processing also in RAM or other type of hard drives. So contents are erased when computer is turned off or reset. A memory unit is an ordered sequence of bytes. Each holds 8 bits. If a byte is the minimum storage unit, no two data can share on or split the same byte. Basically, the smallest store unit in computer is known as byte, B-Y-T-E, and each bit has 8 bytes. So if will be 8 bytes, then it will be 1 bit. And in actual, not any data share two or more than two, or share two or one, specifically 1 byte. If you have a character A, it will be on a specific byte. You cannot write the B or C or D on that specific byte. So every byte has its own specific data. So hard drives, CD drives, and many drives are available for specific type of storage, and these are permanent storage. Sometimes it is are just non-volatile type of storage. So programs and data are permanently stored on storage devices and are moved to memory when the computer actually uses it. Computer languages, as we already discussed in our previous lecture of overview of programming languages. So these are specific set of instructions we have used for specific tasks. So digital devices have two stable states which are referred to as 0 and 1 by convention. That is binary system. We discussed it. So the binary number system has two digits, 0 and 1, or considered as 0 as off and 1 as on. And a single digit is known as bit, as we discussed that one bit has specifically 8 bytes, short for a binary digit. A byte is made up of eight bits. Yes, a byte is made up of 8 different types of bits. So binary language data and instruction numbers, characters, strings, etc. are encoded as binary numbers, a series of bits or one or more byte made up of zeros and ones. So this is known as binary languages. In actual, the languages are the coding and encoding of specific tasks or step of task for a specific function. Encoding and decoding of data into a binary number is performed automatically by the system based on the encoding scheme. If you just give a specific code or data in the form of 0 and 1 to computer will decode that 0 and 1 and will perform that specific function. It is very hard to write a code in binary numbers. Encoding schemes: that numeric data encoded as binary numbers, non-numeric data encoded as binary numbers using representative code, ASCII. It is American Standard Code of information interconnected, as I remember, and 1 byte per character. Another system is Unicode that has 2 bytes per character. So for encoding the specific information in the form of 0 and 1, we have two different types of data systems. First is specifically binary system 0 and 1, and other is the binary system that use specific codes or characters for specific information. So for decimal, there is a base of 10 digits. Will be like from 0 to 9, that will be the 10 digits. However, for binary there will be 2 digits, and these 2 digits, 10 unique values, and in binary we have two n of unique values. As you know, decimal represents the 10 and binary represents the 2. So these are the two binary number systems we have. So here we have American Standard Code of Information Interconnection table. As we discussed that if we will write there are two types of data systems. In first one, we just write the code in binary number 0 and 1, 0, 1, 0, 0, 1. However, if we don't want to do like this one, then we have specific characters that just encode a specific number. For example, if we just want to write a Z, big Z, so we have to write 9, 0. And if we want to write PF, specifically 70, if we want to write S, small s, it will be 11 with 5. So this table just help us to write something. So computers cannot use human language. It just specifically decode the computer language that has specific programming in binary language, and it is very difficult and very time consuming to write the code in binary language. However, most programs are written using a programming language and are converted by to the binary language used by the computer. So people usually just write, researcher nowadays write their codes in different languages, and then there is a compiler or translator that just specifically translate that coding into binary coding, and then computer read that coding for that specific task. So we have three main categories of programming languages: machine language, assembly language, and high level language. We already discussed these in detail in our previous lecture. So here we just have a quick look for all these. That machine language is a natural language of a particular computer's primitive instructions built into every computer. In every computer, the primitive instructions is built by a machine language. The instructions are in the form of binary code, as we already discussed, and any other type of language must be translated down to this language. However, in assembly language, it is like English, like abbreviations used for operations like load R1, load R2. Specifically, English words can use for giving some instructions to the computer. Assembly languages were developed to make the programming easier, because everyone cannot write the specific code in binary languages. The computer cannot understand assembly language. A program known as assembler is used to convert assembly language program into machine language. So here in machine language, there is code is also already in binary. However, In assembly language, code is in English language, or you can say codes of or words or characters of English. However, that coding just translated into machine language with the help of assembler. After that, we have high level language that is also English like language and very easy to write any program to perform a specific task. Suppose here is we have a common example that total cost is equal to price plus tax. This is like a code. So we can use different types of languages for this. However, these languages with the help of different assemblers and translators change into machine language, and then computer can read it. Compiling source, here we have a source file. First we will have a look to this diagram, that first we have a source file, then there will be a compiler that compile and make an object file just link that file, and then we have a executable file that just execute the specific specific task for a specific function. A program written in a high level language is called as source program. Here, as we know that we have just to write a code in high level language, and that is in actually a source file. Since a computer cannot understand a source file, as we discussed that computer cannot understand the source file, computer can only understand the machine language and the binary systems. So there will be a program known as compiler that helps to translate that specific source file into an object file. That is in actual the compiler or translator. So this compiler just help to convert this source file into object file. Then this object file just link it with the linker to the executable file, and then the computer will execute it for a specific function. Any program that is not written in machine language has to be translated into machine language before it is executed by the computer. This means used for translations are themselves computer programs. There are three types of translator programs: assemblers, compilers, and interpreters. So in assembly language, we just studied that there is a assembler that helps to convert the assembly language into machine language, so machine can read it. And in the case of high level language, we have a compiler that just compile the source file into object file, and then link there is a linker that leads to the executable file. So what is assembler in actual? We just have a look to these. So here we just discuss it more in detail, that assembler is a computer program that helps to translate a specific program written in assembly language to a machine language, so machine can easily translate it and perform a specific function. The translated program is known as object program. However, assemblers check each instruction for its correctness again and again, and generate different diagnostic messages if there is any bugs or errors, and if there are mistakes in the program. However, translate mnemonic operations codes to their machine language equivalents, assigning machine addresses to symbols, different types of labels. So assembler directives provide instructions to the assembler itself. That is known as, also you can say, pseudo instructions, that is just not much visible instructions. However, these instruction is useful for performing specific tasks. They are not translated into machine instruction. For example, start and end, from where you have to start from, and at which step you have to finish the tasks or finish that program. The output of the assembler program is called the object code or object program. The object code is usually a machine code, also known as machine language, which can be understood directly by the specific type of computer. For example, you have different types of computers. These computers has the ability to specifically understand that language for the machine. And assembly language is a human readable notation for the machine language that a specific type of CPU uses. So assembly language, like a human can read something, similarly, machine can read a specific language. So assembly language is a human readable notation for the machine language. An object code file can contain not only the object code, but also relocation the information that the linker uses to assemble multiple object files to form an executable program, as we have a look in the diagram in previous slides. It can also contain other information, for example, different types of symbols, different types of notations, different types of mistakes, different types of errors, bugging. So it has to remove all that. and has to fix it for specific or smooth running of that specific function. So that was the story of assembler. Now we have a compiler that is also a program and translate the high level language written program into machine executable form. In actual, assembler and compiler has similar functions that they has to, because they both have to translate or compile or assemble the language into a machine learning language so computer can understand it well and perform the specific task. The process of transferring high level language source program into object code is a lengthy and complex process as compared to assembly language. Why it is so much lengthy? Because there are so many reasons. We will discuss it. Compilers have diagnostic capabilities and prompt the programming with appropriate error message while compiling a high level language. The corrections are to be incorporated in the program when you need any correction. However, the program has to be recompiled. The process is repeated until the program is becomes error free and there will be a smooth running of that specific program. To translate a high level languages source program to a machine code, what is the job of compiler? So compiler has to perform these specific tasks, or compilers built for doing these specific tasks to translate high level language source code to machine learning code, so machine can perform these specific tasks to trace variables in the program, to include linkage for subroutines, to allocate memory for storage of program and different variables, to generate error messages if there are errors in the program. So this is the most important. All steps are very important. However, this one is most important one, that if there will be error, the program will not move correctly. So in the previous diagram, we just have a look to the source code. Then there will be an assembler compiler that just to make it into the object file. Then object file just link and change into executable file. However, in this source code, just there is a compiler and then there is executable file, executable code. High level languages, for example, Java, C++, C compilers are employed for converting that source code into executable code. The compiler displays the list of errors and warnings if there is any problems or any errors in the syntax or semantics of the language. Compilers also have the ability of linking subroutines of the program. Here we have some examples of different compilers available: Microsoft Visual Studio, Bluejay, and different. After assembler and compiler, we have interpreter. So in the main function of interpreter is similar like compiler and assembler. However, those just make the program error free and then make it into executable file. However, interpreter just perform all the steps again and again, and if there is any mistake, it will solve the mistake and then run it again, and all the time it has to run the whole program again and again. The basic purpose of interpreter is same as that of compiler. In compiler, the program is translated completely and directly executable version is generated. As we already discussed, that compiler just make the program error free and then make whole file executable and execute the specific function. However, interpreter just perform all the steps one by one, and if there is any problem in a step, interpreter will not move to the other step, to the next step, and first it will just fix the step and then again comes from the start. Whereas interpreter translates each instruction, execute it, and then the next instruction is translated, and this goes on until end of the program. In this case, object code is not stored and reused. However, in compiler and assembler, object code just stored and you can reuse it when you want to reuse it, or you can make some specific changes if you have slight changes in your task. Every time the program is executed, the interpreter translates each instructions freshly. So here we have some examples of Java of interpreter as JavaScript, Perl, Python that are most usable nowadays. That there is a source code, then interpreter and executable code. Then again next instruction, and this cycle just moves on and on. So there is some advantages and disadvantages of interpreter. So interpreter is good at locating errors in programs because it didn't move to the next step until you will make the you will make that specific step the error free step. Debugging is easier since the interpreter stops when it encounters an error. If an error is deducted, there is no need to retranslate the whole program. However, in disadvantages, it is slow because you have to perform each step and then you have to follow that specific cycle. No object code is produced. If you need the object code, you will not have any object code. However, in compiler, you have the specific object code that you can use it again and again, and you can store it. So a translation has to be done every time the program is running. For the program to run, the interpreter must be present. So in start, we discussed in one diagram that after source code, we have a compiler to the object code, and then object code, and there is a linker that just moves, leads to the executable code. So what is linker in actual? A program that pulls other programs together that so that they can run easily and smoothly is known as linker. It is also a specific type of program that helps other programs for their accurate functioning. Most programs are very large and consist of several modules. Even small programs using existing code provided by the programming environment known as libraries, that if you have a specific type of programs available in the library, you can use it again and again. The linker pulls everything together, makes sure that references to other parts of the program are resolved. So here you can have a look that what is the compiling process: source code, then compiler, object module, linker, and executable version. Here you have assembler version also, and here this is the linker. There is also a specific type of program that helps other programs to run that smoothly. If you want to have a look to the pure interpretation process, then source code, interpreter, output, and you have to give your input at this step. And if you want hybrid interpretation process, this is the pure interpretation process. Hybrid interpretation process, you have a source code, then interpreter, intermediate variant, interpreter, output, and in this one you have to give the input at this point. So compiling Java source code, you can port a source program to any machine with appropriate compilers. The source program must be recompiled. However, because the object program can only run on a specific machine, nowadays computers are networked to work together. So there are different types of black box, and you can say different types of machines just connected with each other to perform specific tasks. So Java was designed to run object programs on any platform. With Java, you can write the program once and you can compile the source file into a specific type of object code known as bytecode. The bytecode can then run on any computer with Java virtual machine. If you have a specific Java virtual machine in another computer, then you can use that specific code in another computer and perform that specific task for a specific function. So Java virtual machine is a software that interprets Java bytecodes. Programming is the creation of an ordered set of instructions to solve a problem with the computer. We already have a detailed lecture on our overview of programming. In that, we discussed that these are the step or series of instructions or steps of sets of instructions to perform a specific task for the computer. Only about 100 instructions that the computer understands. Different programs will just use these instructions in different orders and combinations to perform all the tasks. The most valuable part of learning to program is learning how to think about arranging the sequence of instructions to solve the problem or carry out the task. So in actual, you should know how to use that specific 100 instructions and to solve your query. You have to change the series or to have to change the sequence of these specific instructions, and you should have the ability to arrange that 100 instructions or some instructions from that 100 instructions in a specific way so you can solve your query. So programming fundamentals: putting the instructions together is like sequential programming, a list of instruction in which you have a specific set of instructions. You have to follow all the instructions one by one. This is known as sequential processing. In conditional processing executions, we have so many ifs that if this will happen, then the program will go in this way, otherwise to the other way. Repetition, that are looping loops, for loop like, or different types of repetition, like if you want to add the marks of the student, then you can add the roll numbers and you can add the marks. Similarly, stepwise refinement, top down design, breaking things into smaller pieces, and then you can perform that specific task. And calling methods, if you have a program in any other drive or any other place, you just call the program, and that specific set of instructions will come to other place and perform, specifically calling a segment of code located elsewhere, reuse of previously coded code segment. So method of programming, these are procedural method and object oriented method. In procedural method, there is a specific set of steps to transform inputs into the outputs and translate steps into a specific code that machine can read, constructed as a set of procedures. Each procedure is a set of instructions. Similarly, we have object oriented as a method of programming. However, it just use specific objects or specific things from the real world or real entities, so we can perform a specific task to solve a problem. Basic object programming components has class, object, properties, and methods. So what is in actual class, object, properties, and methods? In class, a specific class specifies the definition of particular kind of object. Similar kind of objects will be in one class in actual. Like if you are in your class, you are 20 students, so each student is in actual object, and total these 20 students are in actual the class. Its characters or properties or attributes are similar, its behavior, so used as a blueprint template to create objects of that specific type. However, in object, a specific instance of a class and object created using the class definition. All specific instances of same class shares the same definition, as we already discussed that in if you are in a class, you are 20 students, and each student is a specific object, and every object has similar functions and similar properties and characteristics, and each class has that specific properties, and these 20 objects has one class in actual. Objects similarly have same properties that can be modified and same methods that can be modified. So for more understanding, here we have an example of class and object. In class, all dogs, we just make a good example that in class we all students, and in object each student has a specific height, specific marks, specific gesture, specific bag. So here in this example, the dogs, we just have a dog as a class, that all instances of class dog have properties. Every dog should have a name, breed, weight, color. For method, they walk, bark, jump, how. However, in object, we have to specify one object that what properties they have, like a dog has a name as Spot, dog has a breed as Mutt, M-U-T-T, Mutt, and then dog has a specific weight that is 10 pounds, specific color of black, and specific type of walking and barking and jumping style. These are the properties of object, and these are present in a specific class. So the most important concept here we have of problem solving. Which expertise we have in our brain to solve a specific problem. We have to break the problem, understand the problem, and then solve the problem. The process of defining a problem, searching for relevant information. First of all, if you have a problem, you have to search relevant information about that problem, how people work that, how much data is available, how many resources are available for that problem, how you can design to design steps to that to solve that specific problem, how to evaluate that the steps you are going to follow is the good one. So these all are the basic concepts you have to be in your mind about the problem solving. So finding an answer to a question, figuring out how to perform a task, and figure out how to make things work. So these three basic concepts you have to be in your mind about problem solving. Not enough to know a particular programming language, must be able to problem solve. There is no need, if you don't know any programming language, no worries. You know how to solve the specific problem. You can give that instructions to your friend or your colleague that are expert in programming, and he will or she will write a code for you. However, you should be expert in solving a specific problem. So Polyas have 4 steps for solving a problem. That is UDIE. U means understanding the problem. You have to understand the problem. What are the pros and cons of the problem? What are the problems of that specific problem? How many resources are present in that how you can understand specifically that problem, and after that deceive a good plan to solve devise sorry devise a good plan to solve. You should have in your mind a specific set of instructions or specific tasks to solve that problem. Suppose you have you are going and the tire of your car just bursted out. So this is a problem. Now you have to find what resources you have, what you have to do for this specific problem. After that, you have a specific plan how to fix that tire. You have to go to the tire shop, or you have another extra tire in your car, so you have to make specific plan. After that, you have to implement that plan, and then you have to evaluate the solution, that the implementation is right or not, what you are doing for to solving that problem is good or not. Suppose if the road is not good and you are just changing the tire, it will burst again, and how you have to prevent all this. So these four basic steps was given by Polyas. Here we have an example that read the problem. First of all, understand the description of problem or scenario. Identify the knowns and unknowns about that problem. What you know about that problem and what people don't know about that problem. You have everything on your paper. Decide how to go about solving the problem. You have to decide which steps you are going to take and for which direction or in which direction you are going to solve those problems. Those problems. Solve the problem, write the solution, test the answer, make sure the answer is correct or not. If the answer is not correct, then you have to change the direction, or you have to change the information, or you have to gather more information to solve that problem. So the first step by Polya is understand the problem. What is the problem to be solved? What is the unknown? What is the condition? What is the data? What is needed to solve the problem? What actions need to take place? So all these steps are included in problem solving or to understand the problem. You have to identify the inputs and outputs for that specific problem, identify the processes needed to produce the outputs from the given inputs. You have to draw a specific figure that just give different notations and different pros and cons and different benefits and harmful effects of that specific problem. Then isolate principal parts of the problem, that these are the core steps of problem that you have to solve that specific problem. After that, we have to devise a plan. Make a plan that should connect with the problem and to help you to solve the problem. The plan should be clear in your mind. The steps should be easy to perform. The steps should be in your resources to perform. So find different connections between the unknowns and unknowns about that specific problems that you find in your previous step. Specifically break the problem into smaller parts and then try to solve all the smaller parts, so you can solve the problem in actual. Design the efficient solution. Make a plan and implement that plan to solve the problem, and then check that this is good one or not good one. So like in computers, we have algorithms, flowcharts, and pseudocodes that helps to solve the problem. Algorithms is a set of series or set of steps to solve a specific problem. And it is clear executable steps that will eventually terminate to produce the desired outcome. Logically designed, used to solve the problems, usually a list of actions required to perform specific tasks. After that, we have pseudocode that is written like a program code, but in actual it is in English and does not have to conform to language syntax. Then we have a flowchart. You guys know well about flowchart. It is a visual diagram that just gives specific steps of yes or no, and there's different types of boxes there. So we have to follow that specific steps to solve the problem. So these you have to design an algorithm, pseudocode, a flowchart for your understanding. After that, we have to implement the plan. Implementation in a programming language, then you have to choose the programming language in which you are expert or you have the expertise, and carry out the plan, checking the preliminary result at each step. Code a little, test a lot. After that, evaluate the solution, that what you done or how you done that specific solution is good one or not for that specific problem. Check the results again and again, it is correct or not. Perform series of steps and test on that data, so you can have authenticated results that the program is working well or not. You also have to think again and again that how you can make it more easy and more efficient. And is this code helps to solve other problems, or if you will change, if you will change minor in this code, and it will help for others to solve different other problems. So these are about the problem solving, that how to solve a problem with the concept of Polya. Four steps: how understanding of problem, devise a plan, and implement a plan, evaluate a plan. Thank you so much everyone for joining.